Hello everyone, welcome to Learn ReactJS for Frontend Development by CodeChef. In today's lesson, we'll be looking at memoization in React and how it affects performance. When working with React applications, components re-render even though their data hasn't changed. While this may not be an issue in small applications, in large and complex applications, unnecessary re-renders will affect the performance. This is where memoization in React comes in. It allows React to reuse previously calculated values instead of recalculating or re-rendering the component. We can use certain tools to make sure the component is re-rendered only when some value changes. So in this lesson, we'll be looking at how memoization works with the help of a practical example. So let's begin. In this lesson, we'll understand memoization in React and how it helps improve performance. We'll focus on three tools: React.memo, useMemo and useCallback, and learn when and why to use each of them. React applications can grow very large. When too many components re-render unnecessarily, the app can become slow. Performance optimization is important to keep the UI responsive, especially in real-world projects. React re-renders a component when its state changes, when its prop change, or when its parent component re-renders. By default, children re-render whenever the parent re-renders. The main problem is that child components re-render even when their props do not change. If a child does heavy work, like looping over large data, these unnecessary re-renders become costly. So what is memoization? Memoization is a technique where we store the result of a previous computation and reuse it instead of recalculating it again. In React, memoization helps us avoid unnecessary re-renders and recomputations. React.memo is used to memoize functional components. It tells React to re-render a component only if its props actually change. If props stay the same, React skips the re-render. React.memo uses shallow comparison. This means React only checks if references are different. If we pass a new object or a new function, React thinks the prop has changed even if the values are same. useMemo is used to memoize expensive calculations. The calculation only runs again when values in the dependency array change. This is useful for filtering large lists or doing heavy math operations. useCallback is used to memoize functions. Without it, a new function is created on every render. useCallback ensures the same function reference is reused until its dependencies change. So let us look at some common pitfalls. Memoization should not be overused. Missing dependencies can cause bugs, and using memoization without measuring performance can make code more complex without real benefit. So when should you use memoization? Use memoization when components are expensive to render, when props rarely change, or when working with large component trees. Avoid it for simple components. To summarize, React.memo is used for components, useMemo is for values, and useCallback is for functions. Memoization is a performance tool, not a default pattern. Use it only when needed. Now in the given task here, we need to optimize this code using React.memo so that the child component only re-renders when its props actually change. Let's first understand what's happening in this code before optimization. We have two components, a parent component that maintains a counter using useState, and an expensive operation child component that performs a heavy computation using a large loop. Every time we click the button, the count state in the parent updates. This causes the parent component to re-render. Now here's the important part. Even though the child component receives the same prop, data equal to hello, it still re-renders every time the parent updates. We can verify this by looking at the console log. Child rendered appears on every button click. This is inefficient because the child runs a heavy loop on every render, even when nothing relevant has changed. Now let us look at why this is a performance issue. The loop inside the child simulates an expensive operation. In real applications, this could be processing large lists, complex calculations, or rendering heavy UI elements. Unnecessary re-renders like this waste CPU time and can slow down the application as it grows. Now let's look at the optimized version here. We wrap the child component with React.memo. What memo does is simple. It remembers the previous props and compares them with the new props using shallow comparison. If the props are the same, React skips re-rendering the component. So let us look at the result after optimizing the code. Now you can see over here, when the application loads for the first time, the expensive operation child component renders once, and at that moment you'll see in the console log, child rendered. After this initial render, click the increment button multiple times. So you'll notice that the counter in the parent updates correctly, the parent component re-renders on every click, but the child component does not re-render again, because the child is wrapped with React.memo and its props never change. React skips all future renders of the child. As a result, no additional console logs appear. If you don't see the log in the console, it simply means the child rendered only once during the initial mount, which confirms that the optimization is working as intended. So the key takeaway is that React re-renders children by default when the parents re-render. Using React.memo, we can prevent unnecessary child re-renders when props are stable, making our React applications more efficient and scalable. So that is our introduction to memoization in React. To really understand this concept, make sure to head over to the CodeChef platform and try out the practice problems yourself. That's where the real learning happens. That was it for this lesson, and I will see you in the next one. Thank you.